We are continuing to learn more about coordinate planes. We have seen earlier that the great French mathematician René Descartes, he was the first person to propose how to locate any point on a plane. So quickly, let's recap what he had suggested. So he said that we take two number lines, place them perpendicular to one another, and we place them in such a way that their origins coincide, and then we define location of any point with respect to each of these two number lines. So this actually is misspelled. This should be there. Now, what he had mentioned is, so here we have taken two number lines. Let's call the horizontal number line x, x dash. So this is the number line. And let's call the vertical number line y, y dash. And both of these number lines, they coincide. So this point is the point which basically is the origin for both of the number lines. So it is customary to refer to the origin with uppercase letter O. Sometimes it is confusing because the O looks like 0, but it is important to realize the distinction. Now what René suggested was that we have to find out the perpendicular distance of this point, let's call it point P, from both of these axes or both of these number lines. So we have the number line x, x dash and the y, y dash. We need to find out the perpendicular distance of this point from each of these two number lines. So he said that we find out the perpendicular distance from the y-axis, which is the y, y dash. And how do we find this out? Well, it is simply we drop a perpendicular from point P on the y-axis, and let's call this point as A. So A is this point where the perpendicular touches the y-axis. So AP is the perpendicular distance. So AP also, because this length will be the same as this length here, right? Because this is 90 degrees. So this is 90 degrees. So this length AP will be same as this length over here. So the distance AP is measured along x-axis, and because of that we call AP as x coordinate. So in our example, AP will be equal to 4 units, because if you see this is 4 units, right? And similarly, to measure the distance of the point P from the x-axis, we have to drop a perpendicular like this, and let's call this point over here B. If we call this point B, then BP or PB, this will be the distance of how far point P is from x-axis, and this distance will be the same as OA, which is measured along y-axis, right? In other words, this distance will be the same as this, and this distance will be the same as this, right? So BP will be then OA, which is 6 units. And so René said that coordinate of any point, we can write this as within bracket x comma y, where x represents the x coordinate. Again, it's very important to understand the x coordinate is really the distance of the point from y-axis, and the y coordinate is the distance of the point from the x-axis. So then we say the point P is basically 4, 6. Now, so when we have the two axes like this, let's write it over here. So we have the x-axis, x, x dash, and y, y dash is the y-axis. So let's write it like that. So we have seen that x, x dash number line, we refer to that as the x-axis, right? And the number line y, y dash, we refer to that as the y-axis. And we have also seen that the origin, we refer to this as with the uppercase letter O, and we call this origin. Now, when we have two such number lines, we see that it has divided the plane into 4 parts, right? So if we start anywhere here and we go in counterclockwise direction in this way, like a clock but counterclockwise or anti-clockwise, so we see that the first part, which is this area over here, we call that first quadrant or quadrant 1. Similarly, as we continue to go from here to over here, anti-clockwise direction, the second area, we call it quadrant 2. So this is quadrant 1, this is quadrant 2. And as we continue to go from here in the counterclockwise, anti-clockwise direction here, so we call that quadrant 3. And as you can imagine, we go one more time before we come to full circle, and the last part we call it quadrant 4. So each of the quadrant, so quadrant 1 for example, it refers to this entire space over here. This whole thing is quadrant 1. Similarly, this entire space over here is quadrant 2. This entire space over here is quadrant 3. And this entire area over here is quadrant 4. Now, also, we will note that the entire plane that we have seen, where we have the 4 quadrants, it is also called as coordinate plane. Let's write it over here. We also refer to that as coordinate plane. P-L-A-N-E. Also, because this entire thing was the idea of the great famous French mathematician René Descartes, in his honor, we also refer to this as the Cartesian plane. Sometimes you will see the word coordinate plane and the Cartesian plane in honor of René Descartes. So we use them interchangeably, and also it is sometimes referred to as XY plane. So they all mean the same thing. Whenever you listen to any one of them, what it means is this entire plane where we have the 2 axes, x-axis and y-axis. This entire plane can either be referred to as coordinate plane, Cartesian plane, or the XY plane. They all mean one and the same. Now, we will note that this part of the x-axis, right? So we said this is x dash number line, and this is the x-axis. So this part which is highlighted in yellow, that is, let's call this point O. So anything on OX, what can we tell about the values of OX? Well, we see that on the right side of the origin along x-axis, these are all positive numbers. So these are all positive numbers, right? So we call this also sometimes the positive direction of x-axis, because all of the values are positive along this side. So similarly, as you can imagine, if we look at this side of y-axis, this is now y dash, right? So on OY, we get all positive values of y. So these are all positive values of x, right? So that is why we sometimes call OX as positive direction of x, because all values are positive. On OY, we get all positive values of y, right? Similarly, you will note that on OX dash, so on OX dash, what can we say of values of x? Well, these are all negative values of x. So these are all negative values of x, and so sometimes we refer to OX dash as negative direction of x. And as you can imagine, finally, OY dash, because of the same reason, OY dash sometimes is referred to as negative direction of y, because all the values on OY dash are negative values of y.